Hey everyone, I hope you're doing well today. In this video, let's simplify down the process of how to solve one-step inequalities. However, instead of using properties of equality, we're going to use properties of inequality instead. When solving one-step inequalities, once you've gone ahead and added, subtracted, multiply or divide both sides of the inequality by a given number, these are some examples of what the solutions could look like, and these are some examples of what the graphs of those solutions would look like. Remember, when your solution inequality just has less than or greater than, you need to place an open circle on the given number and then draw the arrow in the direction with the solutions that make sense. And while those types of solutions have open circles, when you have inequalities that have less than or equal to or greater than or equal to, it's important to remember that we have a filled in circle or closed circle on the given value. Keep in mind that while equations had a finite amount of solutions or a set number of solutions, when we solve inequalities, we have an infinite number of solutions. Well, these are just a few examples of solutions as well as graphs that go along with them. Let's go ahead into some practice problems where we actually use the properties of inequalities and solve some one-step inequalities together. I encourage you to grab some paper, something to write with, and let's do some math together. For example 1, we have the inequality x minus 4 is less than 5. To begin, notice how we have this minus 4 on the left side of the inequality, and we'll use the addition property of inequality to solve this and add 4 to both sides. When we do so, that minus 4 and plus 4 cancel out, and we're just going to have x plus 0, or x, is less than, and on the right side, 5 plus 4 is equal to 9. X is less than 9 is our solution to this inequality, which means any values that are less than 9 make this inequality true. To graph the solution for our inequality, we take our 9 that we got in our solution and put that in the middle, then place a couple numbers that are bigger than it, like 10, 11, and 12 to the right of it, then a few numbers that are less than it, like 8, 7, and 6. Since this inequality has a less than symbol, we know we're going to go ahead and put an open circle on the 9, not a closed circle, and it says x is less than 9, so we have to put this arrow in the direction of values that are less than 9. This is what our graph would look like. For example 2, we have negative 8 is less than or equal to 8 plus y. To isolate the y on the right side, take a look at this positive 8 that's on the same side of it, and we're going to use the subtraction property of inequality and subtract 8 from both sides. On the left side, we have negative 8 minus 8, which is really negative 8 plus negative 8, and that's going to equal negative 16. And that's going to be less than or equal to, that 8 and negative 8 will cancel out on the right side to make 0, and we're just left with a positive 1y. Here we see that negative 16 is less than or equal to y, so if you'd like to turn that around, you can say that y is greater than or equal to negative 16. These mean the same thing. There's our solution, and it means that y can be anything that's bigger than or equal to negative 16. For our graph, let's go ahead and put negative 16 right in the middle, put a few numbers bigger like negative 15, negative 14, and negative 13, and a few numbers smaller like negative 17, negative 18, and negative 19. We know we're going to go ahead and take a look at this greater than or equal to symbol, so we're going to have a filled in circle on negative 16, and because their values have to be greater than or equal to 16, or negative 16 rather, that means that we're going to draw our arrow pointing to the right where the numbers get larger. For number 3, we have w plus 14.9 is greater than negative 2.7. To solve this inequality, we need to take a look at this plus 14.9 that's on the left side and go ahead and use the subtraction property of inequality and subtract 14.9 from both sides. When doing so, those 14.9s on the left will cancel out and we'll just have w plus 0, but we won't write the 0, and we'll have w is greater than, and negative 2.7 minus 14.9. Well, that's the same thing as negative 2.7 plus negative 14.9, and you can check this, but that should equal, I think, negative 17.6. As long as the value for w is bigger than negative 17.6, it'll make this inequality true. Graphing our solution, we can put negative 17.6 right in the middle, we can put negative 17.5 a little bit to the right, negative 17.4, negative 17.3, those are all slightly larger. And we can write negative 17.7, negative 17.8, and negative 17.9 to the left. Those are some smaller values. And also, since we have a greater than symbol, that means we're going to go ahead and put an open circle on negative 17.6. And we're going to go ahead and draw our arrow to the right since we know w has to be larger than negative 17.6, or towards the positive values. This graph represents all the possible solutions for this inequality. In example 4, we have m over 8, or m divided by 8, is less than or equal to negative 2. To solve this particular inequality, notice that our operation is division and we're dividing by 8, so let's go ahead and use the multiplication property of inequality and multiply both sides by 8. When we multiply both sides by 8, on the left side the 8's are going to cross cancel to make 1, and we'll just have 1m, or just m if we don't write that leading coefficient, and m is going to be less than or equal to, and negative 2 times 8 on the right side should equal negative 16. If m is equal to negative 16 or equal to any values that are smaller than negative 16, it'll make this inequality true. Let's go ahead and graph this now. Start by putting negative 16 right in the middle, then some numbers that are larger like negative 15, negative 14, and negative 13. Remember, if they're less negative, then they are more positive or larger values. Negative 17 is a little smaller, negative 18 is even smaller, and negative 19 is smaller to the left here. Looking at our symbol of less than or equal to, we have that bar under it, so it can equal negative 16, so fill it in. Again, when we fill it in, it's allowed to equal that value. And then m has to be less than or equal to negative 16, so let's point in the direction of the values that are less than negative 16. For example 5, we have 60 is greater than or equal to 12t, or 12 times t. So we need to recognize that this operation is multiplication, so to solve it, we're going to use the division property of inequality. Going ahead and dividing both sides by 12 here, we're going to see that on the left side, 60 divided by 12, that's going to equal 5. And on the right side, this 12 and 12 are going to cross cancel with each other to make 1s. And we'll have 1t, but we won't go ahead and write that. And we'll have 5 is greater than or equal to just t. If you want to go ahead and turn this around, 5 is greater than or equal to t is the same thing as t is less than or equal to 5. As long as the value of t is equal to 5 or any values less than 5, this inequality will be true. Looking at this visually on a graph, let's go ahead and place our 5 in the middle here, then some numbers that are larger like 6, 7, and 8 to the right of the 5, and some numbers smaller like 4, 3, and 2 to the left of the number 5. Then going ahead and looking at this symbol of less than or equal to, again we have that bar, which means it includes 5. If 5 is the value of t, that is totally okay. And since t is less than or equal to 5, the other values that are smaller than 5 are to the left. So let's go ahead and draw our arrow that way. For example 6, we have v over negative 4, or v divided by negative 4, is greater than or equal to negative 8. Right off the bat, go ahead and put a star next to this one, or try to make sure you're really paying attention, because something strange is going to happen in this type of example. Notice how on the left side of this inequality, we're dividing by negative 4, so we're going to have to use the multiplication property of inequality and multiply both sides by negative 4. On the left side, these negative 4's are going to cross cancel. We're just going to have 1's or 1v. I'm just going to write v though. And what's interesting that's going to happen here is we're actually going to flip the inequality from greater than or equal to less than or equal to. On the right side, negative 8 times negative 4 is going to equal positive 32. This will be our solution. When solving inequalities, whenever you multiply or divide both sides of the inequality by a negative value, you always have to flip the inequality symbol. The reason why we have to flip the inequality when we're multiplying or dividing by a negative value is because when we do so, we're actually flipping the entire number line backwards. Since it would be really confusing to flip the entire number line backwards, where negative infinity would be to the right and positive infinity would be to the left, we can solve this entire issue by just flipping the inequality symbol the other way whenever we multiply or divide by a negative value. I know this might be a little bit confusing and maybe even annoying, but just try to keep in mind this one scenario where if you multiply or divide both sides by a negative, that you just have to flip the inequality, or else your whole number line is going to be backwards. Looking at this on a graph, let's place this 32 in the middle, then put some values that are larger than it, like 33, 34, and 35 to the right, and put some numbers that are smaller like 31, 30, and 29 to the left. And looking at our symbol of less than or equal to, we know we're going to have to fill in the circle on 32 since it has the or equal to part underneath, and v has to be less than or equal to 32, so those values would be to the left of it on the number line. If you're ever not sure if you flip the inequality correctly, you can always test a value in the solution that you look at on your graph. So since we're dividing by negative 4 in the inequality, I'm going to go ahead and just choose a multiple of 4, maybe something like testing that v is equal to positive 20. So we flip the inequality, so all these values to the left of 32 should work. So if we plug it in and say 20 over that negative 4, that should be greater than or equal to negative 8, right? If we flipped it and we did it correctly. So this negative 20 divided by negative 4 is equal to negative 5. And since negative 5 is greater than or equal to negative 8, it's greater than negative 8, then this does check out, right? If this wasn't true, then we must have flipped the wrong way or we forgot to flip it. So that's kind of like a backup way you can check it just in case. In example 7, we have negative 6y or negative 6 times y is less than 36. This is another example where you have to be careful. To solve this inequality, we're going to have to deal with this negative 6 that's being multiplied by y. To do so, we can go ahead and use the division property of inequality and divide both sides by negative 6. On the left side, these negative 6's are going to cross cancel as planned, and we're going to be left with 1y or just y. The less than symbol is going to turn around to be greater than since we divided both sides by a negative value, and on the right side, positive 36 divided by negative 6 is going to equal negative 6. This will be our solution. And again, since we divided both sides of this inequality by a negative, make sure to flip the inequality from a less than symbol to a greater than symbol. Since our final solution has a greater than symbol in it, it's going to be an open circle on negative 6, and the numbers that are bigger than negative 6 are going to be to the right of it on the number line. If you're still a little skeptical about flipping the inequality symbol, let's go ahead and test a value that's over here. So let's say y is equal to 0, because that's bigger than negative 6, right? So if we test this out, negative 6 times that 0 that we're testing, that's a value that we can use after we flipped, and let's see if that's less than 36. So negative 6 times 0 is 0, and 0 is less than 36, so this must work. If we didn't flip it and you tested a value that is smaller than negative 6, I promise you it will not work. For number 8, here's one final example. We have negative 0.07 is greater than or equal to w over 8, or w divided by 8. To solve this inequality, notice this divided by 8 to the right side, and let's use the multiplication property of inequality and multiply both sides by 8. Because we're multiplying both sides by a positive value, don't worry about flipping the inequality symbol. On the right side, these 8's are going to cross cancel to make 1's, and on the left side, 8 times negative 0.07 is going to equal negative 0.56 or 56 hundredths. And this is going to stay as greater than or equal to. It's not going to flip because we multiplied both sides by a positive 8, and we're left with 1w or just w. And if you're like me and you prefer having your variable on the left, you can turn the entire inequality around and say that w is going to be less than or equal to negative 0.56. Just try not to confuse this as flipping the inequality. We're just turning it around. It means the same exact thing. Graphing this, I'm going to put negative 0.56 in the middle, negative 0.55, negative 0.54, negative 0.53. Those are our values that are bigger. Then to the left, we have negative 0.57, negative 0.58, and negative 0.59 to the left. Since our inequality symbol is less than or equal to, we're going to go ahead and put a filled in circle right in the middle of this number line. And since w has to be less than or equal to it, let's go ahead and put values and point this arrow in the left direction to values that are less than it. And there you have 8 different examples of solving one-step inequalities using the properties of inequality, which are really just saying you can add, subtract, multiply, and divide both sides of an inequality by the same number. The most important key takeaway I want you to have from this video: when you multiply or divide both sides of an inequality by a negative number, or use the multiplication or division property of inequality, make sure you flip the inequality symbol the other way. If you found this video helpful, please consider giving it a thumbs up, and leave a comment down below if you've ever forgotten to flip the inequality symbol. I totally have. As always, keep up the great work, and I'll see you in the next one.